So if you're keeping up with AI, you've been hearing nonstop about these huge do-everything models, right? Well, today we're going to look past all that hype. We're going to see where AI is actually going by diving into two totally different models that are tackling two totally different and really important problems. You see these giant AI models from the big names in tech everywhere, and it's easy to think that's the whole story. But is bigger really always better? That's the question we're asking. What if the future of AI isn't about being massive, but about being small, super specialized, and, well, available to everyone?
All right, here's how we're going to break it down. We'll start by peeling back the hype. Then, we'll look at two big hurdles, the AI power grid and the language barrier. For each one, we've got a cool solution to show you, Hermes 4 and Turk Colbert. And then we'll put it all together to see what this means for the future.
Okay, so before we can really appreciate the solutions, we got to get a handle on the problems, right? So let's step away from the headlines for a second and look at two big issues that are kind of holding AI back from what it could really be.
I mean, think about it for a sec. Almost every big AI you hear about comes from just a few massive companies. And that concentration of power, it creates some real challenges that people don't talk about enough. We're talking about access, cost, even censorship. It's a big deal.
So challenge number one is all about the power grid. I mean, to train one of these big AI models, you need a mind-boggling amount of computing power, and that costs an absolute fortune. So what happens? Control ends up with the very few companies that can actually afford to build these digital power plants, if you will. And this really lays it out, doesn't it? On the one side, you have this centralized model. Think of it like a walled garden. It's controlled, it's expensive, and access is limited. But then on the other side, you've got this decentralized idea, an open infrastructure that uses hardware from all over the place. It's a totally different philosophy, one that's open, resistant to censorship, and could, really democratize AI. Which brings us to our first solution. This is a model that takes that centralization problem and just tackles it head-on. So let's meet Hermes 4. This is an AI that wasn't built in some giant corporate data center. Nope, it was born all over the internet.
36 billion. That's the number of parameters in Hermes 4. And just so we're clear, that is a lot. This is a seriously powerful model. But the real magic here isn't its size, it's how it was made. It was trained on this decentralized network called Nsych, using spare computing power from all over. It completely sidesteps the whole data center model.
You see, the whole point of this model is that it's open from the ground up. It actually uses the Solana blockchain to coordinate everything, which keeps the network stable and, you guessed it, censorship-resistant. And the really clever part? This method slashes the amount of data that needs to be moved around, which makes this whole distributed training thing actually practical. It could totally open the door for more people to get into building powerful AI. Okay, so that's the theory, but how does it actually perform in the real world? Well, they gave it a creative task: plan a 10-day trip to Indonesia on a specific budget. And it kind of fell flat. The answer was pretty generic, and this is the key part, it just completely ignored the budget. Not so impressive. But let's switch gears. They gave it a totally different kind of job, a coding task. Generate a complex, self-contained HTML file with an animated comment. And on this, it was fantastic. The code worked perfectly, it made this cool animation with stars, and it even had a little firework effect when you clicked. So this tells us it's really, really good at logic and coding. All right, so let's pivot now to our second big challenge. This one is a bit more subtle, but it's just as important. It's AI's huge, overwhelming bias towards the English language. See, most of these big models are fed a diet of mostly English data, and that makes them, well, kind of clumsy and inefficient with other languages, especially the really complex ones. So what are we talking about here? We're talking about morphologically rich languages. Think of languages like Turkish or Finnish. A single root word can have hundreds of different forms, each with a slightly different meaning. Now, traditional AIs try to just squish a whole sentence down into one number. When they do that, all that rich, subtle meaning packed into the words, it just gets lost. And that brings us perfectly to our second solution, a model called Turk Colbert. Now, this isn't another do-everything giant. No way. This is a super specialized tool that was built for one specific job, to solve this exact language problem for Turkish.
So here's the difference. Imagine a normal model gives you a kind of blurry, compressed photo of a document. Turk Colbert does something else. It uses a clever technique called late interaction. Instead of a blurry photo,
It creates a unique, detailed fingerprint for every single word. It holds on to all those important details, and that means it can match a search query to a document with incredible precision.
And here's how it manages to be both fast and precise. It's a two-stage process. First, it does a quick, broad search to grab a bunch of documents that might be relevant. Then, and this is the cool part, the exact same model goes back through that list and carefully re-ranks everything to push the absolute best matches right to the top. It's super efficient because you don't need two different models to do the job.
And when I say efficient, I mean it. Check out this number, 1.5 gigabytes. That is the tiny amount of video RAM you need to run Turtle-BERT. It's just nothing. It really shows you how lightweight a specialized model can be. Now, of course, that efficiency comes with a trade-off. It's a master of one specific thing, not a jack of all trades.
Okay, so let's step back for a second. We've got these two totally different models. On one hand, Hermes 4, the powerful decentralized coder. On the other, Turtle-BERT, the nimble linguistic expert. What do they tell us when we put them side by side?
Well, they paint a pretty clear picture, don't they? The future of AI probably isn't going to be one single giant brain that does everything. It's going to look more like a whole ecosystem of different tools. You have Hermes 4, which tackles the big infrastructure problem and is great at things like coding. And then you have Turtle-BERT, which tackles the specific language problem and is a master of semantic search.
So the real takeaway here is this. The most exciting stuff happening in AI isn't just about making things bigger. It's about this fundamental shift, moving away from those general-purpose giants and towards a whole toolbox of specialized AIs. It's about building the right tool for the right job on platforms that, hopefully, everyone can access.
And that really leaves us with a final question to think about. As this kind of technology, the tools to build a Turtle-BERT, the platforms to train a Hermes 4, as it all becomes more accessible, what are the overlooked problems we can finally start to solve? What's that next niche challenge out there that's just waiting for its own perfectly designed AI?